This is a demonstration of seamless integration of the clinical assessment of the patient, the measurement of EEG, and then the application of EEG biofeedback all in one session and in a very efficient and straightforward manner. This is a situation where a patient appears for the clinician. The clinician does a clinical evaluation, does a clinical history, provides whatever tests necessary to assess the clinical status of the patient, and with neuropsychological tests or whatever tests are appropriate, and to determine the severity of symptoms and the nature of the symptoms. The clinician then records 5 minutes of eyes open EEG approximately and 5 minutes of eyes closed EEG, and then saves that data. Then the patient, the clinician, creates a symptom checklist match by first editing the data so it's artifact free, and then immediately begins biofeedback. This is an example of a patient that was struck in the right parietal lobes by a bat and has spatial neglect from the left side of the visual world, as well as does not shave the left side of his face, and has weakness and paralysis on the left side. The EEG has been acquired. There's a large asymmetry in the EEG. We will now edit the EEG and select artifact-free data using the automatic editing routine, which has been discussed in other videos. We'll close that. We can see we have 1 minute and 59 seconds of artifact-free data. We can immediately evaluate the clinical state of the brain for this individual by examining his brain with respect to Z-scores, and see that the right central, right parietal, and right temporal regions are 2 to 4 standard deviations outside of normal, which is consistent with the CT scan and with the clinical history of this patient. We can visually evaluate and show that in fact there is no artifact that was selected. The black is artifact rejection. This is an example where artifact has been rejected that's produced by eye movements. We now go to a report. We can generate a clinical report, but we also can create a symptom checklist match for purposes of biofeedback. We save the patient's symptom checklist, which is the over 5,000 numbers that represents Z-scores from many different metrics. We'll just call this test and replace that. It's now generating the symptom checklist match, at which point we can now begin, when it's completed, the collection of EEG for purposes of biofeedback. I'm going to use the playback feature in NeuroGuide. I'm going to click Setup and Monitor, and then bring in a data file that I had saved from this patient. But we could actually be recording EEG from the patient at this time. This is the same patient's setup panel. This is the EEG streaming across the screen as though it's actually being recorded in real time. And now we can begin neurofeedback. I'll go to Collection, Neurofeedback, LORETA Neurofeedback. This is neurofeedback of networks of the brain that are linked to the patient's symptoms. The first screen is a protocol panel, and what we're going to do in this screen, we can select any broadband area we want and regions of interest if we wish, because the goal here is to treat the dysregulated nodes and connections between nodes in the networks of the patient's brain that are related to the patient's symptoms. I'm now going to go to the symptom checklist that I just saved in the previous period. We called it test, and I'm going to select that symptom checklist. Now our symptom checklist panel comes open, and we can look at a variety of symptoms, and in this case the symptom for him is orientation and space problems, and he's fairly severe. I will give him a 10 for severity. On the left are the nodes and networks predicted to be deviant from normal given his symptoms, and these are based upon PET scans and functional MRI literature of several thousand studies. The match section here are those aspects of the patient's brain that are deviant from normal and are the same as those hypothesized to be related to the patient's symptoms. The mismatch column here are probably compensatory or the deviant activity that's not related to this particular symptom. We can reduce the number of deviant selected problem areas by increasing the z-score. This is the 4.5 standard deviations, and now we're just focusing on the right parietal lobe and nothing else. Or we can select more. In this case, it's just 1 standard deviation. That means anything that's deviant of 1 standard deviation or greater has been selected for purposes of biofeedback. We can also use the output of a neuropsychological test if we wish and select one of these particular aspects of the patient's workup. The Department of Defense is using NeuroGuide for the purposes of assessment and treatment of soldiers with PTSD and mild traumatic brain injury, and that's a list here you can see that is used there. Or we can just go straight to networks if we want. For example, this is the dorsal attention network or ventral attention network or default mode or executive mode or language or memory, etc., based upon the patient's symptoms. Again, we want to link the patient's symptoms to dysregulated nodes and connections between nodes. We're also going to be looking at a current being generated by Brodmann areas as well as the coherence between Brodmann areas, phase differences between Brodmann areas, as well as phase shift duration and phase lock duration. We can also look at the intrinsic connectivity networks. It's based on approximately 30,000 PET scans that show high consistency in these various networks. So there's a variety of options that we can deal with. Right now, for demonstration purposes, we're going to just focus on the perception in space and orientation of space problems that this patient has. I click OK, and in this case, we can see we select actually 202 variables. I'm going to set this threshold a little higher to 2. You can evaluate exactly which Brodmann areas were selected as far as current or power. This is Brodmann area 7, and there's delta, theta, alpha, beta that was selected. Here's coherence. There's various combinations of Brodmann areas and frequencies that are deviant from normal and related to the patient's symptoms. Phase, phase shift, and phase lock. And all these frequencies were selected because these are all deviant from normal. I'm then going to click apply. Well, before I do that, I'm going to go to rounds, and I'm going to just do 1 minute of recording, and then there will be pause in which you can then interact with the patient, and you can also evaluate the progress. So the session rounds are set for 1 minute per round and 30 seconds between rounds, which gives time for the clinician to interact with the patient and encourage the patient to change their own brain using EEG biofeedback. We now will click Begin Session. I selected this particular display that we can move to the patient's screen if we have a second monitor, but we also can use DVDs, multimedia players, and various other types of stimuli to give feedback to the patient, and then we can also look at the progress that the patient is making. So the patient is actually looking at this green dot, and the goal is to keep this green dot on as long as possible. The instantaneous z-scores are shown here in the right, and the progress of the biofeedback is shown in this bottom screen. The top panel here is the percent of time that a reward is actually delivered or a feedback signal, indicating that the threshold set in the protocol panel has been met. And so we are continuing on for about 1 minute to just demonstrate what LORETA Z-score biofeedback is like, in which we target specific Brodmann areas. In this case, the client in this playback got a total score of 28 rewards in 1 minute. That indicates learning. We want to get somewhere between 20 and 30 scores per minute, and not too many and not too much less than that. And we want to be able to see a progression over sessions of control by the patient of the display, which indicates that learning has occurred or operant conditioning has occurred, in which the brain has been modified by virtue of EEG biofeedback. And specifically what is being modified are the Brodmann areas or the nodes of networks and the connections between those nodes that are linked to the patient's symptoms. And we then can terminate this to end the session. We can save the session data and call it test for now, so that we can then, when the patient comes back, we can look at the progress of that patient over over sessions, to see to what extent the patient's brain has been modified, and then of course clinically evaluate the reduction in symptoms as due to the biofeedback procedure.